Alright, let's plug rebar right into the beam. Okay. Well, this one is different elevation. We are having a sort of stirrups. It goes like this. Okay. Well, and here we got some longitudinal bar, bottom three numbers of 20 mm. Okay, if I take a kind of a cross elevation, I got a stirrups. Okay, and the rebar goes just like this, and it could be called as a 180-degree hook on both sides. And stirrups, let's talk about stirrups. For the first few distance, maybe the span of the beam can be 3 meters. For the first 1 meter, the spacing of the stirrups, I don't know, these and all data actually come from the structural engineer. For the first 1 meter, the stirrups of 8 mm diameter carry kind of a spacing of, well, 100 maybe, I don't know. And for the next 1 meter, it will carry a spacing of 150, as that will be greater than what we have provided here, as the shear force is much lesser right at the center span. Okay, for the next 150, for the next 1 meter, the spacing goes to 150, or let it be 200. In here also, the spacing goes 100. My sole aim is to show you to insert the rebar as stirrups and change the spacing and adjust the spacing of the stirrups based on some random arbitrary distance. Not to teach you how to calculate all these things. You are awesome structural engineers, you know how to calculate all these things. Okay, right? So let's plug right the data into Revit structure. Is take up a beam and taking up a concrete section. I'm not considering the size of the beam, as 300 by 600 is far enough for me, and the size of the beam will be 3 meters. So that's it. Next thing, I'll like to get into the elevation, get into the shaft elevation. Here you have the beam. Next thing, you like to select the beam and gonna get into rebar. Okay, picking up the rebar, I like to have 180-degree 1C section right there, and I like to place it right near to the cover reference. Okay, and the placement plane will be always parallel to work plane. Okay, then you can place it like this. And also, let me just give him a name of a schedule mark. It will be called as a bottom bar. Okay, and got 3 numbers of bottom bar, fixed number of 3. Okay, so you know the bottom section is clear. We have 3 numbers of 20 mm diameter bar at the bottom of the tensile zone here. Now let's consider what's gonna happen right at the top part. Okay, for the compressive zone, either you can select the asset and go rebar, pick up the section, or simply it's possible to mirror. You're gonna pick it up to this, and I like to have 2 numbers, and this one goes to schedule mark will be the top bar. Alright, okay, so what we're gonna do here is I like to get into the 3D view right now. And you can see that there are 3 numbers of bottom bar and 2 numbers in top bar. Okay, so let's turn up the visibility states. So that's all about the case, what happened in the longitudinal bars right in compressive zone and the tensile zone. Now let's consider the stirrups. So in order to place stirrups, I like to get into the east elevation. Alright, you might not able to see the rebar until you get into the fine and the wireframe view. Okay, so now what we're gonna do here is let's try to place a stirrup right there. So pick up the rebar. I would like to have stirrups, some kind of stirrups like this. Okay, alright, if you place it, you can see that the rebar adjusts automatically right into here. Okay, so what we can do in here is we'll get into the south elevation, fine, and wireframe. Alright, you got to see the bar is like this here. So we could have a spacing of 100 millimeter right at these three sections right here. Okay, so let's get into the maximum spacing of 100 millimeter. Use up the bar to drag it up. Before drawing up anything, let's split this asset right into 1 meter parts. Okay, so for that, get into reference plane. I like to have the spacing of 1 meter. Pick line, and one is here, the other one is here. Okay, so right away snap this bar into this part. Alright, okay, cool. Then you can copy the bar from the first point to the no, it will stay right here to the cover, and one can be right there. Okay, all these will carry a spacing of 100 millimeter, and in between the spacing was restricted into 200 millimeter. Okay, so for that you can copy the same thing using the first point, and you can have the second point right here. Okay, click on overlap, and now you can like to turn off this, so the first bar has been turned off. Now you can adjust this spacing right into 200. Okay, alright, and drag it up to here, and I like to turn off the end bar. Alright, that's all about the spacing of the bar. Alright, if you like, you can like to change up the name right into stirrups. So all the drawing sections have been completed. Now let's try and tag it up. So get into annotate, and I like to have the multi-river annotation tag right here. First, I like to duplicate the tag and give him a name as the diameter and spacing. Okay, and we're gonna get into here, and let's place it right here. Okay, trying to select the tag and edit the family and edit the label. Right to have the bar diameter and the spacing right there. So spacing center to center. Okay, load into the project, and alright, okay, 10 millimeter center to center. I like to decrease the scale for this first part, and also select the asset, right click and create similar. Right in here, 10 millimeter 200. Right in here, 10 millimeter 100 200. Alright, so that's how we will tag the rebar. And also like to have one more thing right there. So it's alright, now we got the tag right in elevation right there. Now get into the east elevation. Like to have the number, we got have three numbers, number and diameter will be right there. So get into annotate, and I like to have the multi-river annotation right here. Duplicate, this will be like number and diameter. Okay, we will be handling everything right in the structural MRA rebar, multi-river annotation. Then let's get into the placement. You might feel that the tag is very big or bigger size, or again anytime decrease the size right in here. well, I didn't like the placement. Once again, well, same procedure. I select the tag and edit the little family, and well, edit the label. I like to have the number and the diameter. Okay, so we can have the number and the diameter, bar diameter. Okay, so that's it. So it fixes three numbers. Okay, three numbers. Okay, that's kind of a cool thing. And let's load this into the project right here. Alright, so three numbers of 10 mm, and you can select the same as it. Right click for create simulator. Alright, I could place it right at two numbers of 10 mm diameter bar. What's the main advantage of this kind of thing is, if let's select the rebar and trying to change it right into maybe I like to have 16, I could see that the tag will get updated automatically. We don't want to wait for that. So that's all about MRA. Now if you're trying to get into the schedule part, all we can do here is well, get into new schedules, and I like to pick up a structural rebar, and alright, okay, so right now we don't have any spacing for this longitudinal bar. Okay, got a schedule mark. There's a blank right there, so let me just try to go there and pick it up. This is a longitudinal bar. Wow, that's okay for now. I got longitudinal bar in tensile zone and longitudinal bar in compressive zone. Right, okay, that's cool. So we got three different sort of stirrups here, having 11 numbers, and the spacing is also okay. So now let's try to calculate the well, the total mass or total weight to be ordered right in Revit structure. So right, get into schedule. I like to create a field and add a calculated parameter. This one will be the mass of the rebar. Mass. So first, let's get into, okay, this one will be the kilogram. This will be mass of the rebar. Mass. This will be a structure, and the asset will be a mass. The formula will be reinforcement volume into 7850 kilogram per meter cube. It's kind of a volume of the asset right there. Alright, okay, so let's try to do one more thing. That let me try to filter just by the schedule mark header, and I like to turn up the total. Turn up the total for the mass. Show up the total, and also well, that's enough. And also the quantity is actually not required, but just for fun, let me add the quantity too. So we got the longitudinal bar in the compressive zone. Okay, orders 3.7 kilogram. Bar in the tensile zone 15 kilogram. Let's create a new sheet and load up a sheet right from, well, it's a kind of an A3 paper. Alright, okay, so what we can do here is let's drag and drop the kind of a view. I can drag a elevation view right into here. Okay, well, I need to do some tweaks right here. It goes like, we can have the crop view and crop region visible, and drag it up. Right, so if we wanna try to get into the rebar view, you can fill up the steps just like that. You can take any print out of it, and also if you feel that the asset is too small, you can scale it. So placing up the schedule right here, and also like to have the front elevation that comes to be the east elevation here. So drag and drop the east elevation. You know, the size always matter. You get into east elevation, drag and drop the east elevation. Okay, this is a great video for you.